architect, a lady architect. This is positive discrimination, but she is very successful, and it is an honor for me to announce such successful women in their field. Now I'd like to invite Ingrid Dominic Meisinger, and she will be talking about the building examples and construction into a passive house. And for that reason, I'd like to invite her to the floor. I believe this is going to be a very interesting presentation.
Hello, thank you for your
Merhaba.
invitation, and I'm happy that I have the chance to present some of our projects in Austria here in Istanbul to show how can we use these details, these informations, and to bring to some buildings. I have 3 projects. I will start with the first. It is the reconstruction to a passive house of a multi-story building in Linz. Here a short map of Austria. Linz is situated in Upper Austria. It's the capital of Upper Austria. It has 1.38 million inhabitants, not so much than Istanbul. You can see on the right side some typical pictures of Austria. Very typical are the mountains with the snow. That can be very cold in winter, but also very warm in summer. In former times, we always thought over how we can reduce the heating demand, because we only thought that it is necessary to think over heating. In the last years, we also know in summer it becomes very warm, also very important to think over the cooling demand. We have seen a slide in Robert's presentation. Here is the existing stock, about 150 up to 300, and because of some regulations it falls down to the low energy house, and now we are in the area of the passive house. The renovation of houses is a very great chance, because we have buildings, they are maybe 30, 40 years old, and we can think over that they become a new shape, that they become new energy efficient. We can upgrade them, we can beautify them, we can enlarge them, we insulate them. It is a new chance, but we have the chance only for this time, and we make a bad renovation, then we forgive this chance for the next 30 years. When we renovate it today, we will not renovate maybe in 10 years. Here you can see the old building. It is a multi-story building situated in Linz. Picture after the renovation, but I will begin in the basics. Here you can see this building with 50 flats inside. It has a west-east alignment. It is the south side is attached to a neighbor building, and it has an open northern front. This is the Market Street. This is the main street to Linz, to the center of Linz, with a high traffic. There is a high air pollution, and it is very loud. On the picture you can see a little bit there are balconies, and because it is very loud and because of the air pollution, they never use the balconies. And they don't like to open the windows because of the loud traffic. I know this is a problem in many cities. Here another picture of the old building. The construction of the building is alright. It was built in 1947. It is the outside walls were constructed out of wood concrete with a U-value of about 1.4. Later they applied on some parts of the cellar ceiling insulation and on some parts of the roof. But the windows, the doors and so on, they were not in the current state of technique, and it was not a will later show you what we did with them. So what was the motivation of the owner of the social housing company, and the motivation of us? It was necessary to renovate. This is what was not so that the owner thought, oh, maybe I will renovate, but it was necessary. The windows were old, the heating costs were high, and it was necessary, and therefore they thought over what they can do, and they decided together with us they don't want only to renovate, they want to renovate to a passive house. Also, it was the motivation to make a pilot project to collect experiences for other projects. And this renovation was the first renovation of a multi-story block in Austria with passive house. What were the aims? One aim was to bring down the heating costs to the minimum, an optimized airing and building services concept. You have heard we have the high traffic outside with the air pollution, and we want to bring in a very good air. We want to make an ecological renovation with renewable resources, because it is a building with tenants inside living. It was not possible to move them out. We had to renovate when the tenants were living inside. Therefore, it was necessary to make a renovation without disturbance of the tenants, of the residents. Therefore, we used a high degree of prefabrication. We saw this slide before. Very important, the closed envelope, to think over the airtightness, to think over the details. And so we started. This was our first computer picture, and here we decided this will be our thermal envelope, that we can look, that we can see and say, what will we do with the facade, what will we do with the balconies, with the roof, and so on. And with the first calculations, we decided that the cellar will not be in the thermal envelope. We will start at the ground floor. And because it was not able to cut the load-bearing walls, and the cellar was not very high, we could not put on maybe 30 centimeters of insulation. Therefore, we only reached a low-level standard in the first floor, in the ground floor, and from the first floor to the upper floor, we reached the passive house standard. So, we started with the facade. We decided to make prefabricated wall units because of the time and because we wanted to use a wooden subconstruction. Here you see the aim piece of our facade. It is a honeycomb facade made out of paper. Here you can also see one of these prefabricated elements, and we included nearly everything. The windows, the sunscreens, the ducts for the ventilation system. It has been one apartment width and one apartment high. Like this, it was brought to the renovation project. Here, some explanations about this special solar comp. Because we wanted to use special systems, special materials. Here at the front side is a glass to protect this wooden honeycomb. It is pack ventilated, and this solar honeycomb, it works with the sun. When the sun is very low in winter, the radiation of the sun comes inside the solar comb and warms it up. You can see here at day it nearly becomes temperatures up to 60 degrees, but not only on the middle area of the solar comb and not on the back side. And in summer times, when the sun is standing very high, then because of the back ventilation, the temperature is much lower, therefore it's no problem to shade this facade. Here we can see the construction in the manufactory. We used at first a wooden subconstruction, then inside insulation system with 25 centimeters. On it there were fixed the elements with the solar honeycomb. Here the prefabricated wall unit integrated the windows and the slices for the mechanical ventilation system. Before we started, it is necessary to know if we can fix these elements on the outside walls, if the structure is good enough. Therefore we made some holes to find out if the structure is good, and they found out that in the area of the normal outside exterior wall was not good enough to fix the elements, the wooden elements on it, but in the area of the ceiling there is the reinforced concrete ceilings, there it was possible to fix them. Therefore, you can see it here in the pictures. We used at first a wooden subconstruction, which is mainly fixed in the area of the ceilings, and between it was then insulated, and on this wooden subconstruction all of these elements were mounted. And here you can see the balconies I mentioned before. They were not used because it was too loud. The air is not, the air is so polluted. We decided at first to cut them off, but the owner said you cannot cut them off, you cannot take it away. And then we decided to bring them into the thermal envelope, and we enlarged them a little bit so that the tenants can use them like a small winter garden. Here the detail I explained before. This is the wooden subconstruction because of the static. This one we fixed in the area of the ceiling, and between there is the insulation, and this is the whole element integrating the insulation, the solar honeycomb, the glass, and the window. It is a triple glazing window with an air shading system inside the window between the outside glass and the inner glass. And what you hardly can see is here the old window. We left the old window inside the construction when we were mounting the elements, and when the facade was closed we broke down the old window from the inside, so the apartments were never open. Because this kind of renovation is a very exact renovation, and because of the prefabricated wall units, every part, every window has to fit absolutely exact. Therefore we measured before the building with a 3D laser scanning. Therefore we get points from each window, and these points we sent to the construction firm, and because of these coordinates they made their plannings for the elements. Here you can see again, here is the thermic skin. On the roof we put on it 40 centimeters of insulation, and to the cellar only 15 to 20 centimeters because we had not enough space. As we heard before, now we got a very good thermic envelope. We tried to avoid every thermal bridge, and therefore that the people become a very good fresh air inside, and that they don't use to open the window. We decided a single mechanical ventilation system. We compared many of them, but we decided a single mechanical ventilation system which is mounted only in one room. For maybe an apartment with a living room, a sleeping room, a kitchen and a bathroom, we need two of them for an apartment with 3 living rooms, we need 3 of them. And how it works: from the outside, the fresh air comes in. It goes over the heat exchanger, and the fresh warmed up air comes inside the living room and then circulates over the kitchen and the bathroom, and the extract air goes back to this mechanical ventilation system, goes over the heat exchanger and goes out to the outside. On the other side, we only use it for one room. Here you can see this system is a very small, only 50 to 50 centimeters, with 3 steps, on, out, and here you can see the cubic per hour, 50, 30 and 60. There are 2 filters inside. Here are the filters, and they have a heat recovery of about 73%. 73% of heat recovery is not very much, but we decided this system because we had not enough space in this house. There were not enough space for maybe a central mechanical ventilation system, and so this was the best decision. The electricity power has 4 to 12 watt. It's not so much, yeah? When you compare with lamps, for example, is 12 watt very low. Here you can see it again. Here you can see it mounted on the inner side, and when we started, we make these 2 holes for the fresh air and the exhausted air. Then the pipes were fixed in the prefabricated wall units. They has also been scanned by the 3D laser scanning, because they also has to fit very exactly. And then the elements were mounted with the slides and the ducts for the ventilation system. Here you can see the characteristics. Before, the heat requirements were about 107.9. We could reduce it to 14.4. This is a heating load before 118 to 11, and there are another, for example, the outside wall 1.2 to 1.4, and depends on the side of this building, because the solar honeycomb works with the sun and with the orientation. It has 0.082 watt per square meter Kelvin. The roof 1.9, 1.09, and so on. Because we enlarged the balconies, we also enlarged the heated area from 2,755 to 3,000, and therefore it is a massive reduction of CO2 emissions. What I didn't mention before, we had an existing heating system inside this house with a district heating. We left this heating system, but we reduced it. It's not possible for the tenants to open. Maybe they get 30 degrees inside. We reduced it, that they only can use very less energy. The tenants, they are also a very important point in the phase of the renovation, or before you start to renovate, because these are 50 apartments inside. And when you start to think over to renovate such a building, you can be sure that not every tenant will say, oh, this is a very good idea. Many of them will say, oh, why do you want to do this? You really think that it will work? Is it not too expensive? I'm not sure if I want to do this. I don't want to have a mechanical ventilation system. And therefore it is very important to meet these tenants, to tell them what you will do with their house, what are the benefits in future for them, that they can bring down the money for the energy costs. And what were their characteristics for the tenants? Before, the heating costs were not so high because we have a very compact house. But you see, before the renovation, we have heating costs per month about €51 for an apartment with the size of 60 square meters. And after the renovation, we could bring down it to €4.7. After the renovation, the costs for the heating are nearly the cost as was it before for 1 month. And how it is with the renovation costs? The renovation costs are €77.4 per square meter. Renovation up to a passive house. We calculated it with a conventional renovation to compare, and the difference is not so high. How was the financing? There was a financing from Upper Austria, the funding for grants. Then, because it was a research project, we got a unique subsidy of the House of the Future program over €300,000. And the last point was that the tenants had to pay about €1.46 per living space per month since 1983 to the social housing organization, and from this money, including all of them, it was calculated and paid. Here you can see some pictures again, the old building, the computer plan, and after the renovation. These were the partners of this project, and to remember, we bring it down 179 to 14.4. We have a better quality and we have less costs and a greater architecture. Where no worm gets lost, no new worm has to be produced. So this was one project for social housing companies for how to renovate multi-story buildings, and nearly the same system we tried with another project, with a school project, to show also in schools we can use the similar system. But in schools I think we have another motivation, because the motivation for our architects also should be, and not only for us, also for our society, is that the education of the children is a very main focus. And I think it is our responsibility to ensure that the next generation is educated in energy efficient, CO2 neutral buildings, that they have the chance to get the best air quality, the best thermic quality, for more chance of success in school if you have a lower CO2 concentration in the air. And also in this case it was the chance to transform an old building to a newer form, to achieve a very low primary energy consumption, energy efficiency, and a very high user comfort for the children and for the teachers. This project is situated in Austria, also in the south of Austria, in a small village with the name Arnoldstein. Here you see Italy and Slovenia. It is near the border to Italy. Here a few area picture. Here is the situation, and here are the mountains, and here is Italy and Slovenia. The sun hours in December are about 3 to 4 hours. There is a side map, a small village with an existing school. Here is the school, and the village is growing very fast, and everything is concentrated around the school and the church. The school is a renovation, and one part of this building is a kindergarten, and we use the situation of the primary school to make an annex of the kindergarten to use the synergies. Here you can see the old building with also the old building has a very good general structure. The exterior walls, which were built in 1964, were constructed out of reinforced concrete with a new volume of about 0.4 or 0.5, as not very good. Also the cellar ceiling, the attic, the window door, it was very old, and it was also necessary to renovate. Here you can see a chart of the schools in Carinthia, and in the area of the 60s to the 70s, the most of the schools were built, and now is the period to renovate them. Here the side map. This is the elementary school, the primary school. In this area, the annex for the kindergarten, and here the gymnasium, which we doesn't renovate. The old building, the annex building. Here also the thermal envelope to look where are the details to go through and to see what is with the windows, with the walls and so on. Also the section drawing, the thermal envelope everywhere has to be closed. Here in this example, the basement is also in the thermal envelope. Here is a computer rendering. I will show you two details. Here is a detail of the attic. This is the old part of the building with the reinforced concrete, with the ceiling, and only with 11 centimeter of insulation on it. And also in this project we use prefabricated wall units. Also on the roof, here you can see this prefabricated wall unit with a TGI, with a timber construction inside, and 40 centimeters of insulation. And the outside walls also a wooden subconstruction for the static, the wooden construction, and inside this wooden construction the insulation with 30 centimeters. Here the window, the position of the window in this area of the insulation. Every detail is airtightness, is airtight, and to think over the overheating, we mounted a sun shading system on the outside, which is on this layer of the outside facade. Another part of the building, of the kindergarten building, here you can see the triple glazing windows in the position inside the insulation, and here the windows airtight fit to the wall, and the outside also the sun protection. Here are some pictures of the renovation. Here you can see the energy bus, the energy calculation from Austria. Before it has 121 kilowatt hour per square meter Kelvin. We bring it down to 7.8 with the energy bus. And here to show you the PHPP, the special calculation program for the passive house. It is a little bit higher, 12 kilowatt hour per square meter and per annum, because the calculation is a little bit different. We see it before, the CO2 concentration, but in this case of a school class, this is 8 o'clock, this is 9 o'clock, you see this is 1 hour. And between 8 and 10 o'clock in the morning, the CO2 concentration goes over 2,000 parts per million. And this is too high for our children. They become tired. Yeah? They cannot listen to the teacher. It is very hard to follow him. And when we use a mechanical ventilation system, we are in this area of the blue line. The red line is the CO2 concentration without a mechanical ventilation system. After 2 hours, they have opened the windows, it falls down, but after 1 hour again, it is again on a volume which is too high for the schoolers and also for the teachers. Here I have the plan for the mechanical ventilation system. In this case, it is situated in the basement. It is a central mechanical ventilation system here in the cellar, and here you can see the ducts which go to the classrooms. Here you can also see them. It goes to the classroom. You can see it on the next picture. Here are the pipes. We can see them all. Also here in, this is the kindergarten. Here is a school class. Also here you can see these pipes for the ventilation system which bring the fresh air, the warmed up air to our classrooms. Because we said we want to make a renovation with renewable materials. The materials they were looked over is if we really use the materials which we wrote down in our plans, and this is one certification of the materials. So here I have another pictures from the construction phase. Here you can see the reinforced concrete columns, and because the static is very good, we could fix the elements on these reinforced concrete columns. Also included the windows and the sunscreens, but no ducts for the ventilation systems because we have the ventilation system situated in the basement. Here is the annex of the kindergarten. This is the old part which we have seen before, the renovation of the old part, and here is the new part, the annex of the kindergarten, also with prefabricated wall units. You can see it here, but in this case the windows were not mounted because they were too big. Another picture of it. Here you can see it when it was finished. Here you can see the mountains. So, also the old picture of this building with 121, we brought it down to 7.8. So, this was my last slide, and I say thank you very much for your attention.
Çok teşekkür ediyoruz. Şimdi kısa bir kahve molası verme zamanı. Yaklaşık 20 dakika sonra tekrar bir